Hello everyone, I received the MacBook Air that came in for no power under the scope. This is the board number. This is A20000165A, alright? So this is a MacBook like 2015 to 2017. This is the kind of MacBook it is, okay? So I already pulled the motherboard, the customized motherboard out, and there is it. And then I just want to share with you how we can fix these kind of MacBooks, okay? So first of all, I'll start by bringing in this one. This is the DC in board, and this is what will allow the computer to charge. This cable is responsible for giving you the green light or the amber lights. Without that, you won't have that. So once this is properly plugged in, your battery may charge. You may have the green lights or the amber light. All right. So I have my DC supply, and then this is the charger. So, and like I said, from the 2015, this particular board number, without a known good battery, without a known good battery, it won't power on. It's going to turn on, and then it will be stuck at the charging sign on the screen. So if your battery is not good, this laptop will never power on. All right. So we connected our charger, and there is no amber light, there is no green light, whatever. So I want to start by checking the PP bars. So meter in volts mode. So meter in volts, I'll start by checking the PP bars, and the PP bars is okay. We should have the battery voltage here. Even if I take off the charger, you should have the battery voltage here. That's a known good one. So once plugged in, the first right after this is on, you should have PP3V42. That should give you the amber light, but still we're not having it. So probably we are having an internal circuit with our SMC. So let's see if you have our first 5VS4, 5VS5, and no, 3V3S5, no. So these are like an important power rails. So I want to share is an open board data that has all of the MacBooks, most of the MacBooks, and its power sequence. Okay, so I don't know who, but probably Paul Daniels created all of this, and then this laptop's Apple. This is the board number. So if you're having an issue with your backlight circuit, this one can help you diagnose that. So for now we are having an issue with our power. It doesn't turn on, so we're going straight to the power sequence. So looking at the power sequence, it says we have PP bars J3 Hz, which is supposed to be 8.2 volts. So we have 8.17, approximately 8.2 volts. Then it goes to SM bars, is the communication SMC. So once there is a good communication with the SMC, we should have PP bars J3 Hz to be 8.56. So the fact that we are stuck at 8.2 means that there is a poor communication, or there is something wrong with the SMC. Alright, so mostly what you can start by reflowing the SMC. Sometimes you can just start by reflowing the SMC, and it works. Mostly maybe liquid got to it, so if you just add more flags and reflow it, it works. Sometimes it doesn't, but then let's see, because now we are stuck at But here we are stuck at this point. This is the last rail that we are seeing on this rail. Okay, so it should be 8.2 for Air and 12.2 for the MacBook Pros. So now we know we don't have 8.56. It means that we are stuck at this point. Okay, so there is nothing under, there is nothing after this that's going to show on the power rail. Okay, so now we need to figure out why there is no communication with the SMC to the motherboard. Okay, you know, every controller has an input and an output. So if it has the input, it should definitely give you the output. Probably probably with this motherboard, it's having an issue with the inputs or the output. So you're going to check with this schematic and the board view diagram if you are having the inputs or we are just missing the output for this one. So I'll go to the board view, and then this is the SMC. So I'm going to check on the PDF. As you can see, we have you know, all of these have meanings. Okay, all of that have meanings. So now we just want to be sure that we are having the inputs and the outputs. With this, I can think of the input as this and that. Okay, this and that. So let's see. So we are checking the VREFA plus, and it says it typically refers to a voltage reference input for an analog to digital converter on a microcontroller or other integrated circuits. It's often used to provide a stable voltage against which the ADC can measure input signals, ensuring accurate and reliable conversions. The A in VERFA plus usually indicates it's associated with ADC channel A, and the plus sign denotes the positive or the high side of the reference voltage. Okay, so we know that that is our inputs. So we're going to check on the board view. So this is it. So we're going to check here on the, so that's on the board view. That's, we are going to check something around here. I'm going to bring in the scope, and as you can see, this is the SMC, and this is what we are talking about. So we want to see if we are having the inputs for this particular, and we have 0.136. I don't think this is a good voltage. It should be a minimum of about 3 volts to power this chip so that it can give an output. Okay, so we are going to take off our power and remove the battery and put our meter in diode or in ohms mode, and we're going to measure on that capacitor, and it's a 5.8 ohms to ground. So back to the schematics. So we have 5.8 ohms to ground on this. So this is a capacitor. Whenever it's shorted, it goes to 0. Okay, capacitors, when they are shorted, it just goes to 0. So the fact that we are having like 5.5 ohms tells me that this chip is the bad one. That's the SMC is the bad one. I don't think this one is shorted. So neither are these two capacitors on the same rail. So I'm just going to take off this chip, and I'm going to remove this big capacitor as well, and then we will see which one is the bad. Other than that, like I suggested, I know this is bad one, this is bad, so I'll just leave the capacitor. We can always remove the capacitor easily, so let's just remove this one. So my air is set to 100 and temperature is about 420. So I'm going to preheat this area just about a minute, just to make sure then I'll just focus the power here, and then I just want to make sure this one is all the balls under this chip are melted. All right, so just about a minute. So just like that. So I'm just going to take it off. So our SMC is off. So let me just keep it here, and then we'll wait for the motherboard to cool down a little bit so that we can check which one is the short. So now we are checking, and we have like we have like mega ohms. So meaning this one is a bad boy. So this is bad, and then we need to replace this SMC. So this is the part number. So this is the part number, and we need to replace with the same part number, 980. So I have few donabots, so I'm going to scout for one, and then you have it rebuild and put it back to see. So I found this. So I found this donor, and I want to check if we are having the same part numbers. So that's LM4F S1EH, LM4F S1EH. So they have the same parts number, and I want to make sure it's the same board number as well, and it's the same board number. So we can remove it. So we can remove this, rebuild this, and then install it to see if this is going to fix this computer or this motherboard. It didn't come off evenly, so we are going to rebuild this chip. Let's just start by rebuilding this chip, and there's about 227 degrees solder paste. So just give it a little bit of time, and then the balls are going to melt. Just like that. Then you continue to hold it a little bit just to be sure all of these parts goes dry. Okay, other than that, it's going to, you will have to rebuild them once more. So now our chip is rebuilt and we just want to add some flux, then we can reflow it together so that all of the parts, so that all of the pins can, you know, stay strong to the parts. Okay, so now all of the balls had properly seated on the parts of the chip. So now this is ready. So this is the older chip and this is the newer chip. Okay, so we're going to install this back. So we will need to clean the chip. So I'll first add some low melt with this, with all of these parts. All of the parts are flat and they are ready for the new chip. So I want to clean this flux residue before I add a fresh one. So now I'm going to add fresh flux just like that. Then I'm going to align the chip. This is the rebuild IC. I'm going to align it so this starts, then you align it just like that. That's so. Now this is properly aligned, right? So this is pin number 1. So you just want to see if all of the balls are solid. Yes, everything is. So we just want to reflow it one more time. That's good. This is properly seated. So you want to clean. So you want to clean everything. So we have so now you want to test if you are going to have green lights on the charger. Did you see that? The fan is spinning. We just scored another goal. Wow. So we connected our battery, and then now it's the moment of truth. Yep. You have our green lights, fan spinning. That's all for today. So I have reset the SMC because we are on a new SMC. And there you go. This laptop is a fix. Thank you very much for watching. I hope you like the video. Please like and subscribe. And I will see you in my next video.